Alright, so what we're going to talk about for a little bit in this video is the idea of density. Now, density is really just going to be a measurement of how much mass something has versus its volume, or the ratio of mass to volume of an object. We represent density with the equation density equals mass divided by volume. So what that really is it's just a ratio. Density at the end of the day is a ratio of mass to volume from any object that you might have. So for example, let's take a few minutes here and look at an example problem. Let's look at an example cube here. So this cube is a three-dimensional object that's going to be important. Looks something like this. Right, so this is a three-dimensional object, which means it has a volume. It's an object, obviously, so it has to have a mass. Mass is really just a measurement of how much matter is in this thing. So we can find out the density of this object. So let's say that this object here has a mass of 24 grams. And let's go even further and start talking about the volume of this object. Now this is a cube. So one of the ways you can find the volume of a cube would be to measure the length, multiply it by the width, and then multiply it by the height. The volume of any object is really just the three-dimensional space that it takes up. If I take the length of this cube and multiply it by the width of this cube, and then multiply it by the height of this cube, I have the volume. So let's go ahead and say this is a cube, so that means that all these sides are the same. The length we'll call 2 centimeters, the width we'll call 2 centimeters, and then the height we'll also call 2 centimeters. So this would be me taking out a ruler, measuring this distance here, and this distance here, and finding out that they're all 2 centimeters exactly. So what does that mean? That means that my volume is going to be my length of 2 centimeters times my width of 2 centimeters times my height of 2 centimeters. Oops, I mean to put a C in there. So my volume here will be 8 centimeters cubed. Now one thing I want to point out before we go any further is this cubed, this 3 up here, is very important. It's telling you what kind of measurement you have. Volume is a measurement of three-dimensional space occupied. So the first dimension is across here, this length 2 centimeters. The second dimension is the width, the next 2 centimeters, but the third is the height. So that means that we multiply centimeters times centimeters times centimeters. That means your units are centimeters cubed. Units work just like numbers when you multiply them, right? If I took 2 times 2 times 2, that's really just 2 cubed, or 8. Same thing with the centimeters. Centimeters times centimeters times centimeters is centimeters cubed. Volume can be displayed in multiple different ways. You can talk about volume as being how many centimeters cubed. You can talk about volume as being so many milliliters or liters. Usually that's when we're talking about a liquid. But there's multiple ways to represent volume. They're all reasonable. So in this cube, we have a volume of 8 centimeters cubed. We talked about a second ago how our density was mass over volume, right? So if I take my mass and divide it by my volume, I will have my density. My mass was 24 grams divided by my volume of 8 centimeters cubed gives us a density here of 24 divided by 8, or 3 grams per centimeter cubed. It's important to recognize how this is really just a ratio, right? It was a ratio of 24 grams to 8 centimeters cubed. We can reduce that ratio, right? We can divide the top and the bottom by 8. 24 divided by 8 is 3. 8 divided by 8 is 1. We don't have to write the 1, so it just becomes 3 grams per centimeter cubed. This would be the density of that cube.